I've done data visualization applications and products in a wide variety of use cases. That includes at places like Apple and Netflix for use cases like algorithm discovery, performance, content delivery at Netflix, real user monitoring, and a bunch of academic stuff at Stanford and so on. Wrote a couple of, or three, I guess, editions now of a book about D3, which is the primary technology for data visualization in JavaScript. Made a data visualization library called Semiotic, which is a React-based data visualization library, and co-founded the Data Visualization Society. So I have done a lot of data visualization throughout my career. Before Confluent, I co-founded a company called Notable. It's an analytical notebook company using AI and BI integrated into sort of a Jupyter notebook base, which, not surprisingly, had a strong data visualization component. And what I want to talk to you about today is real-time data visualization. And I want, hopefully, to have you walk through the expo hall after this with a different gaze. Because when I walked through the expo hall this morning, what I saw was a whole lot of tables, and I occasionally saw a line chart. Saw a lot of flashy, moving, cool stuff that was pre-recorded video. And then when you actually saw the, hey, we're showing you the results of your streaming data, it was for the most part tables and line charts. So I want to talk about, well, what do I mean by real-time data visualization? What is it? What are the practical aspects of it from the perspective of someone like me who's an information designer? A quick look at what's already out there, and then make a try to convince you that we should do something more sort of focused on real-time data, streaming data, and making products that emphasize that streaming quality. I'm sorry, I keep getting distracted by this. I don't know if I'm the loudest speaker you've had so far, but this thing's getting lower and lower as we go. So why do we need real-time data visualization? Well, this audience doesn't need to be convinced as to why we need real-time data, right? Because when you want to do something simple that's not going to bother anybody, like introduce surge pricing at a grocery store, you need real-time data to do that. You need to have, as we saw in the keynote, or I'm sure as most of you have seen in your daily practice, you need to have access to real-time signals in order to make changes at the moment of sale or in real time. I would argue, though, that for you to understand whether or not that's working, and for you to consider what the next step is with that, that you need a way to see how that's performing. And that's why we need real-time data visualization, and I would argue a sort of native real-time data visualization. Oh, I'm sorry, I always put these jokes in here, and I'm told I should explain them. This is not uncontroversial, in case you don't know. People are rather upset at the idea of surge pricing at your grocery store. To do that, I want to emphasize, for what I assume is a lot of sort of back-end engineers in the audience, that this is a design problem as much as it is a technology problem. In fact, it's more a design problem than it is a technology problem. And so we have to think about what the personas are who are going to be using real-time data visualization and the purposes of that visualization, for which I want to gesture at three broad purposes for real-time data visualization that I've seen in my time at Confluent and elsewhere. One of those is, of course, operational visibility. I think that's where we see the most maturity in real-time data and applications that support technologies like Kafka is. Operational health, you want to make sure your streams are set up properly, that they're emitting and consuming and processing things correctly. But you also want, and this is a use case that I had at Netflix, where we built a real-time aspect to the A/B testing platform. You want to make sure that changes that everybody thought were going to be fine don't screw up the system. And you want to find out about that as quick as possible. You don't want to find out the next day after the ETL is run that you've introduced a change because of what you thought was a pretty well-designed A/B test that caused everybody to stop watching television on Netflix, right? If that's happening, you want to know about that in real time. So there's a lot of cause no harm situations, I think, that we could address with real-time data. And then finally, and I think most excitingly, is actual real-time decision-making with real-time analytics. So domain experts who are making decisions that they could not make with batch results, that they could only make in real time because you've made them aware of patterns that exist in real time. And so what do I mean by real-time data visualization? Because I'm sure that all of you have looked at a Datadog dashboard that is giving you real-time results. I want to talk about how the products that we build, from a design perspective, have to reflect the fundamental aspects of the material that we're working with. By which I mean all of the dashboards that you see that deal with real-time data visualization, for the most part, look exactly like batch data dashboards. And so when you create products that look exactly like something else, then you don't enable or empower your users to understand the technologies underneath so that they can help you to design more sophisticated uses of them and also to envision new metrics and new decisions that can be made with them. So I don't have to go into detail about what real-time data is for an audience like this. But there's another aspect to real-time data visualization, and that is that as we grow in our integration of AI into everything that we have, then even if the data is actually being updated every day in sort of a batch way, then you still have a metadata layer that could be operating in real time. So for a long time, I've tried to build collaborative data visualization products. It's been very challenging, not from a technical perspective. We did some cool stuff at Notable where multiple users could be in the same notebook at the same time, making changes, leaving comments on a data point on a chart and having a conversation about it. And it was really sophisticated, really, really cool. But we couldn't actually get multiple users to work in the notebook at the same time. It was still very much like an individual-oriented task. But now that we have AI agents, you always have a collaborator available. And then also there's the AI use case. I mean, the classic AI use case of going into ChatGPT and having a conversation with an LLM, which is itself a real-time event. And so even though what we might see in the products that are developed to support technologies like Kafka, there already exist a lot of examples of real, more sophisticated real-time displays out in the world that hopefully all of you are familiar with. Hopefully everything on this, for the most part, should be recognizable to you. So I want to walk through them and sort of typify them a bit. Right? Every video game you see like this is fundamentally a heads-up display. Now, granted, it's not reality. It's a simulated reality of, I don't know, orcs fighting whatever. I actually don't know how this game works. But layered on top of that is an unobtrusive data visualization telling you the health of your opponents or their available skills, their available ammunition, and allowing you, if you want, to get more information about an individual unit. And it's done that way because, as we know with regular dashboards, information overload's a real thing, and information overload is particularly dangerous if you're already in a task-oriented environment that requires a lot of thought and effort. And if you make a display that's too obtrusive for video games, then maybe people don't enjoy the video game, maybe the video game doesn't sell well, maybe it doesn't do well in multiplayer or something. But if you do that with a car where you also see heads-up displays, then somebody's going to crash into something. So we have to be aware in this use case, if what you're presenting is sort of a layer of information on top of reality, whether it's simulated or not, how we present information and how we make sure that information is available to users on demand so that they can zoom in when they need to for details. Flow density, I've done a lot of work with GIS, and I've done a lot of work with transportation network models, so this is one of my favorite examples. And this is where we get into a very interesting tangent with real-time data visualization. Now, I talked about tables, and I talked about line charts, and I hope I I told you with the tone of my voice how disappointed I was by that. And I'm sure many of you also said, well, what about maps? Like I see maps all the time. In fact, I use Google Maps or Apple Maps. I worked at Apple, so I should say Apple Maps, because I still have stock and it's still got to go up. And it's real-time data visualization. It's telling me that, oh, there was an accident here, traffic is getting worse, and it's encoding it, and I'm dealing with it, and it's a sophisticated interface. You have views like this. We'll see some views later that are map-based views that are very challenging, that are very advanced. And you might think, well, that's because it really works for geodata. Geodata is a separate use case, and it just for some reason works. And it's not. It's because people are familiar with maps. Data literacy, and the fact that most of us were taught about maps in 7th grade means you can be a lot more ambitious with information displays when that information display is layered on a map. And so what I'm suggesting is that we bring that level of sophistication to other views. Because what bothers me about this is I can go look at this view for cars, for ships, for people, for livestock on a map. But there's no view like this for people moving through a funnel in an application, whether it's a website or not. You don't have that same sophistication when we look at a host of other flows through systems. And so what's important about these kind of views, what they'll give you is they give you two different perspectives. They give you an operational perspective, and they give you an analytical perspective. And the operational perspective, like I was saying, was about health, right? I want to make sure this system is functioning right. But more than that, it's about scan and summary. It's the same reason why tables are so powerful. That's the two modes of a table, scan and summary. A summary tells you, roughly speaking, this is the how many records I have. Some tables that are well-designed also maybe tell you the distribution of values. Maybe they give you a little sparkline or something like that. And then they let you scan through it to find an individual item. And these kind of maps do the same thing, right? I can see, roughly speaking, the health of these freighters moving through the San Francisco Bay Area. And then if it allows me to zoom in on one of them and go look at a particular row of data, in this case, that would be a ship. And so we often think about the purpose of analytical applications to be impact, insights, results. And that's important, and it's measurable, and there's going to be KPIs, and you can at least sort of track that in another dashboard. How good is my dashboard's dashboard? But the other purpose of these applications is to actually satisfy a user who is concerned and allow them to consider other opportunities to use this data. So what I mean by that is if I have a view that my customers or my stakeholders can log into and see that things are going fine, that's of extreme value. And then if while they're there, they think about, oh, well, what could we do to optimize this better, to go in different directions with this, to maybe develop a second order metric from this. Maybe from this we come up with, instead of the individual paths, we bundle the paths. You could imagine a PM, right? Talking about we bundle the paths, or we bundle the trajectories, or we bundle whatever. And they get that because they're seeing the visual representation of it. And that's of extreme value. Another real-time data visualization use case, which I hope people are familiar with, I hope you're not too familiar with it, because it would imply that, I guess everybody's probably been in a hospital room at some point, is the classic sort of health monitoring machine in an ICU or other sort of hospital. And the value of this, the design of this is purposeful, because the experts who are monitoring your health don't know which of these are the most important metrics. So they can't design it in a way that it's all about your heart and then you've got sort of secondary context. Because it might not be. It might be that your heartbeat or your oxygen levels are context for something else that's going wrong. And so that's why it presents a bunch of sort of simultaneous views. That's why it promotes big number views rather than complex data visualization. And it gives you some history, but not much, because it doesn't want to, you don't want to confuse your stakeholders. Another sort of more sophisticated and more modern example is probability contraction. For those of you, oh, that's me. For those of you who aren't familiar, the needle, the sort of jittery needle up at the top, was from the election, the U.S. election. It's been rolled out. I believe it was rolled out before the Clinton-Trump election, but the Clinton-Trump election was the one that really drove people crazy. People said that they developed anxiety seeing this because they were so invested in the results that to see something going like this and telling you your life is over, everything's fine, your life is over, everything's fine, it hit them. And so, but there's also another way of viewing probabilities that's very common, which comes in sports, where you can see the win probability over time for two teams in competition with each other. And so with the teams over time, it gives you the current value, which is, you're going to see this sort of, we'll return to this as a design principle over and over again, which is that you give the current value and you give some kind of historical tail. And also you encode uncertainty when you can in ways that you can. That's what the jitter is. This isn't, they're not collecting individual votes. They don't have a sensor on each voter telling them 3 more people just voted for Trump. There's a probability in there that's determining the range of the jitter in the needle as the night goes on. And what I think is important about this, with the not so much the needle, but people do bet on elections, is that you can develop secondary products. So once people are familiar with probabilities of when probabilities changing over time, then you can have them bet on that. You can have them bet in the middle of the game. You can have them bet 3/4 of the way through the game. They can bet when they think it says 99%, but I don't believe it, right? And that is a product that could only be offered if you educated your customers such that they understood what was going on in real time. I would also argue that any chart like this, and anybody who has followed sports probably has seen this and gotten very frustrated like this, any chart like this where it touches 100% visually at some point in there, somebody needs to go back and adjust that model. So, and which I'm sure they're probably doing, but you can see a chart like this where the Seattle's win percentage touches 100% multiple times somewhere in the early third quarter, late third quarter, early fourth quarter. I'm sure it's 99.2%, but you shouldn't be telling somebody that the win probability is 100% and then later they lose. That's bad probability. Finally, and that's part of the vetting that model, what this allows you to do, again, from that sort of satisfaction perspective, is trust but verify. You know, if I look at this needle and it's kind of going like that, then I realize, well, there's a chance Clinton's going to win and there's a chance Trump's going to win. And so you have to deal with that. But if I see that needle and it's going all over the place, like if it was going all over the place in a gauge in your car, if you're old enough to remember cars that actually had needles, then you'd know something was wrong with the system. So that's the other thing that it allows you to do is look at system health. So another source of real-time data that we see a lot of visualization about is models that converge, right? Because each of the ticks in these models costs money. Eventually it comes to the point you could run it forever, but eventually it gets to a point where it cools off enough where you say, hey, this is optimal. And data scientists do use visualization for this. They use it to do force-directed network layouts. I love network visualization. I won't get into that in too much detail. But typically what they use to tune these models is not visualization. They use summary statistics. They find the parameters that are important. They set some kind of threshold. When those parameters reach that threshold, they declare the model to have been successful. The problem with relying on summary statistics to make your decisions is the same problem of relying on summary statistics to make your decisions across analysis, and the reason why we have data visualization. So this is Anscombe's quartet. This is the only interactive part of the talk. How many of you know what Anscombe's quartet is? Excellent. So Anscombe's quartet is a collection of 4 data sets. Each of those data sets, you see the little orange dots, very, very different. The summary statistics for all 4 of those data sets is exactly the same. The median, the average, the min, the max, everything is, looking at it and trying to figure out. if the max is exactly the same. The max is obviously not exactly the same. Just looking at, that's the power of data visualization. But the summary statistics for it beyond that are exactly the same. And so what it's saying is if you rely on summary statistics, you're going to miss the fact that these are 4 very different patterns. And the same thing is the case in machine learning. So how do we make real-time data visualization? Well, you have to engage with what we refer to as encodings in data visualization. So encodings is just the technical term for when you take a categorical or a numerical variable and you encode it in a certain graphical channel. So I take the number of sales and I encode it in the length of a bar for a bar chart. That's encoding. And there's all sorts of different encodings. There's encodings around enclosure, color, texture, shape. The stuff that we really know, length and position, we know because it works really well. And so there's another set of encodings that we haven't thought about, or I should say we, in the field of data visualization, haven't thought about very deeply, that relates much more fundamentally to data that is being updated in real time. And that's animation. You see a lot of animation used for demos and never for the product. The fact that things pulse as they update, that you see a lot more trajectories, you see a lot more arrows and other sort of graphical derivatives of what's in the process of happening, probability contraction in the form of like probability ranges or error bars, things like that. And we need to invest more in leveraging these to build distinctive products that are optimized for real-time data visualization, for real-time data. And so what would that look like? Well, there are things like hierarchical encodings, which I'll get into in detail. Actually, all these principles I'll get into detail, so I'll leave this slide for the people on YouTube who watch this talk later. But hierarchical encodings, what do I mean by that? As I said in the past, we want to know what the current value is of this thing that's updating in real time. But stakeholders also want to know whether this value is within some kind of range historically that makes sense. And what they might be asking is a range that maybe makes sense for a short-term decision or a long-term decision. So when you go onto Google and ask them what the price of a certain stock is, it shows you the current price, it updates it while you're looking at it, and then it gives you 1 day, 5 day, 1 month, 6 months, et cetera, windows. So you can have some sense of whether or not the volatility or movement, motion of the stock, its current motion is exceptional in the context of its historical movement. Another very basic principle that I'm kind of surprised that we don't see as often is that in design, if something is alive, it has to move or pulse, right? We see it in video game design, where characters don't just stand there like a statue. They always have that sort of video game, I'm not moving motion, right? In video games, you don't have to animate a person walking across a screen. They're not really walking across the screen. There's no physics involved. You're just doing that to signal to the customer, to the stakeholder, that this thing is moving, and it has some kind of, it allows them to get some kind of sense, expectation of how it's moving and where it's moving. I love this example, and I was really happy to get it. I was looking at the Confluent stock price, and while I was capturing the GIF, the stock price didn't change. But it pulsed, so it let me know this didn't change because it's the same, which is very different than this didn't change because it wasn't updated. And then finally, for this sort of small batch of examples, when you open up Instagram or Twitter or X or whatever it's called, you don't look at it and try desperately to read it as it streams past your face, right? You open it, you see real-time updates, and then as you're looking at it, a little thing pops up that I'm very Pavlovian about, right? I see this, like when I see this, I hope some of you got the same thing of like, oh, I wonder if I should update and check and see what's been posted since then. It lets you know, since you have looked at this, things have changed. Now for Twitter, that's pretty simple. It just says, hey, some people posted, and here's a sample of some of the people who posted. For your analytical applications, maybe it's a little more sophisticated. Maybe it's, hey, things have changed since you opened up this dashboard. This thing is on fire. Maybe you should update, right? But that's because we have more than just a simple social media app. And so what's out there? Well, this is, I'm not trying to shame anybody because I think that for the most part, real-time data visualization, the focus has been data access. How do we plug in? You see it all the time. This dashboard plugs into such and such technology. In 5 minutes, you'll have a dashboard, from whatever, whether it's real-time or batch sources, which is important, and it's critical to usability. But then the actual dashboard that's produced looks exactly the same. Like fundamentally, if I told you that this was being fed from an iceberg table or a living Kafka stream, you wouldn't know the difference based on the presentational elements. And I think for engineers, it can be hard because the engineer's like, well, I know what this thing is running, and I have a mental model of how it works. But for the customers, for our stakeholders, who could meaningfully interact with us to help us build a better product, if we present them a view that tells them it's exactly the same thing as when they're working with batch, then they can't, it will be harder for them to understand that this is a fundamentally different technology. And this is what happens when you run something live, but I will show it as a slide like this. There's a lot of entertaining real-time data visualization out there too. This is HatNote, which is all the updates of Wikipedia since you opened up this page, just being sort of splatted at you as circles. The size and the color indicates the amount of the size of the edit or the category of the page. There's another one that shows you the world population updating, and there's a third one that's one of those wind simulations that we're all familiar with, whether it's Null School or Windy or whatever, that shows the map. That's the one that apparently didn't load. What's interesting is world population is not because, again, there aren't sensors on every pregnant woman or dying person. That's a model. So it's just like I was talking about with the machine learning examples. This is just a model, and they're visualizing that model in real time. HatNote, those are actual changes from an actual sort of real-time data source. And then all of these wind simulation examples are all sort of a mixed mode, where it's using animation to show you that, hey, this is happening right now, but we're simulating the current trajectory of how the weather is changing. I'll go back into oh, look, there it is. Beautiful wind map showing, I think, a hurricane coming toward Austin again. That's why I come to Austin. It's for the weather. And so what I'd like to push us to take this seriously and produce products that are distinctive to the data that we're working with, rather than building what look like Tableau dashboards that are connecting to Tableau extracts that are coming from a SQL data source, from an ETL that's updated every 2 to 3 days. And what does that mean? Well, what that will allow for is that if we design it well and it's using these principles of information visualization to show systems that are in motion, then we will increase the data literacy of our stakeholders, and they will be more inclined to engage with the fundamental principles of the systems that we're using to produce the data that they're operating with. And also, they'll be more inclined to support the investment in real-time technologies because it actually makes sense to them, rather than just being vaguely different than the data sources that they know. And we can then continue to build up together. If you want to go fast, go alone. If you want to go far, go together. Like, let's pull our customers and stakeholders in and build things together and build more ambitious and more sophisticated real-time metrics and real-time use cases, because now we all understand the systems better because we can see them. And then I want to reinforce what I'd said earlier, which is that even if you're not using Kafka, even if you're micro-batch, it was funny at the speakers meetup last night. I was at a table with a bunch of engineers who really knew Kafka, and they were having that sort of moment where they were saying, well, do you really do real time? And they said, well, my stuff only updates every 15 seconds, so it's not really real time. All views nowadays could be said to be in motion because of collaboration, because of AI integration. You could really think about how all views are active and not just minted that morning and static until the next morning. And then I kind of like this gesture. This is a landscape, this is a painting, this is static. It's got value, and it's got a certain kind of value. But if you make it a system, then it becomes something that people can think about and design for and build. And to get a little less abstract, this is a schematic. Okay? Anybody who's played with DAGs, you can build this very easily. If we add animation to it, and I love people taking pictures of it because then you're not going to capture the animation, which I think is great. If I add animation to it, it becomes a system. And as you're dealing with animation, this is using gradient animation to encode the throughput and the performance. It's fake, so it's not. But there's all sorts of things we need to figure out when it comes to the display of this, because do we use those? Is there a value to gradient encoding of the transmission of data through a system? Or should we be using particles? Or should we be using the sort of dash offset technique? There's a lot of different ways that we could encode this data in motion that we haven't sufficiently explored and studied. But then also, I've shown a lot of animations here, and animations are great. Animations are really pull people in. That's why we use them for all the demos before we get to the actual product. It's just a line chart and a table. But like a bar chart race, these things are gold on Reddit. I have watched people who have told me, shut up, I need to see how this ends, looking at a bar chart race, and they're great. It's very engrossing. You want to watch it happen, and you can see the system sort of converge onto something and stabilize. But also, you're watching it, and you're watching it, and that's a lot of time that you're drawing from your stakeholders. So make sure that you're using that effectively. On the right there is the exact same data set presented in a static mode using what's called a bump area chart that actually encodes the exact same data over time. And what it does show you is that right at the end, Nigeria makes a real race up to, I think, 6th place that you just don't catch because the animation's over and it resets. So we have to make sure that as we're deploying these new techniques, that we don't just create a video game version of Kafka, that we have something that people can meaningfully interact with, can meaningfully digest and understand, and create more sophisticated, not just views, but products from that. So I want to end this with a call out to Jay's keynote. Jay said this morning, I thought it was a really powerful statement. He said, you can't have after-the-fact governance. If you have after-the-fact governance, you're going to get into these situations where things fall apart. And really, I think if we don't have real, solid views into these real-time sources that we have, into the streaming data, then everything's after the fact. If everything we have looks like batch data, if everything we have is presented to ourselves and our stakeholders as batch data, then all of the decisions we make to a certain degree come after the streaming has happened. So that's where I'll end it. If anybody has any questions, I'm happy to take them.